The control of air pollution has become a matter of great importance in our society. Air pollution adversely affects human health, vegetation, materials, and the environment. Many of the pollutants enter the atmosphere from sources that are currently beyond our control. The principal sources of these pollutants are human activities. These activities are related with our living standard. The elimination of these activities will cause a decrease in living standard, therefore, this action is not considered. The remedy proposed is to continue the activities and control the air pollutant emissions by removing them from polluted streams. Some of the major pollutants are carbon monoxide, oxides of nitrogen, hydrocarbons, oxides of sulfur, and particulate matter. Particulate matter is the sum of all solid and liquid particles suspended in air, many of which are hazardous. This complex mixture contains, for instance, dust, pollen, soot, smoke, and liquid droplets. These particles come in many different size ranges, such as coarse, fine, and ultrafine. They also vary in composition and origin. They are present in the atmosphere in very large number and cause severe air pollution. These particulates have severe effects on humans, plants, animals, materials, and environment. Keeping in view the effects of particulates, its control is becoming increasingly important. These suspended particles vary in size, composition, and origin. It is convenient to classify particles by their aerodynamic properties because these properties govern the transport and removal of particles from the air. They also govern their deposition within the respiratory system, and they are associated with the chemical composition and sources of the particles. They range in size from less than 10 nanometers to more than 100 micrometers in diameter. Coming towards the sources of particulate matter. The sources are divided into two major types, the primary and the secondary sources. Primary sources are derived from both human and natural activities. Natural sources of particulate matter include sea salt, dust such as airborne soil, and pollen, but it also includes material from volcanic eruptions and particles formed from natural gaseous precursors, for example sulfates. A significant portion of particulate matter sources is generated from a variety of human activity. These type of activities include agricultural operations, industrial processes, combustion of wood and fossil fuels, construction and demolition activities, and entrainment of road dust into the air. Secondary particulate matter sources emit air contaminants into the atmosphere and form or help form particulate matter. Hence, these pollutants are considered precursors to particulate matter formation. These secondary pollutants include SOxes, NOxes, VOCs, and ammonia. Control measures that reduce particulate matter precursor emissions tend to have a beneficial impact on ambient particulate matter level. Some important industrial sources of particulate matter emissions are iron and steel mills, the blast furnaces, steel making furnaces, petroleum refineries, the catalyst regenerators, air-blown asphalt, and sludge burners, cement industry, asphalt batching plants, production of sulfuric acid, production of phosphoric acid, soap and synthetic detergent manufacturing, glass and glass fiber industry, and instant coffee plants. There are much more and many more examples. Let's discuss some of the health and environmental effects of particulate matter. Let's first discuss about health effects. The size of particle is directly linked to their potential for causing health problems. Small particles that are less than 10 micrometers in diameter pose the greatest problem because they can get deep into your lungs and some may even get into your bloodstream. Exposure to such particles can affect both your lungs and your heart. Numerous scientific studies have linked particle pollution exposure to a variety of problems, which includes premature death in people with heart or lung disease, non-fatal heart attacks, irregular heartbeat, aggravated asthma, decreased lung function, increased respiratory symptoms such as irritation of the airways, coughing, or difficult breathing. People with heart or lung diseases, children, and other adults are the most likely to be affected by particle pollution exposure. Coming towards some of the environmental effects. Fine particles like PM 2.5 are the main cause of reduced visibility, which we often call haze. Particles can be carried over long distances by wind and then settle on ground or water. Depending on their chemical composition, the effects of this settling may include making lakes and streams acidic, changing the nutrient balance in coastal waters and large river basins, depleting the nutrients in soil, damaging sensitive forest and farm crops, affecting the diversity of ecosystems, contributing to acid rain effects. Particulate matter can stain and damage stone and other materials, including culturally important objects such as statues and monuments. Some of these effects are related to acid rain effects on materials. Now let's talk about some general methods and technologies for the control of particulate matter emission. There are 5 types which are worth mentioning here. Number 1, gravity and momentum collectors. Number 2, centrifugal collectors. Number 3, fabric filters. Number 4, electrostatic precipitators. And number 5, wet particulate scrubbers. Let's first talk about gravity settling chambers. This is a simple particulate collection device using the principle of gravity to settle the particulate matter in a gas stream passing through its long chamber. The primary requirement of such a device would be a chamber in which the carrier gas velocity is reduced so as to allow the particulate matter to settle out of the moving gas stream under the action of gravity. This particulate matter is then collected at the bottom of the chamber. The chamber is cleaned manually to dispose the waste. The gas velocities in the settling chamber must be sufficiently low for the particles to settle due to gravitational force. Literature indicates that gas velocity less than about 3 meters per second is needed to prevent re-entrainment of the settled particles. The gas velocity of less than 0.5 meters per second will produce good results. Curtains, rods, baffles, and wire mesh screens may be suspended in the chamber to minimize turbulence and to ensure uniform flow. The pressure drop through the chamber is usually low and is due to the entrance and exit losses. Some advantages of gravity settling chambers: low initial cost, simple construction, low maintenance cost, low pressure drop, dry and continuous disposal of solid particles, use of any material for construction, and temperature and pressure limitations will only depend on the nature of the construction material. Some disadvantages of the gravity settling chambers would be large space requirements, and only comparatively large particles greater than 10 micron can be collected. Because of the above mentioned advantages and disadvantages, settling chambers are mostly used as pre-cleaners. Use of settling chambers as pre-cleaners can also reduce the maintenance cost of high efficiency control equipment, which is more subject to abrasive deterioration. Now let's talk about Cyclone. Cyclone is an example of centrifugal collectors. Cyclone separators, or simply cyclones, are separation devices that use centrifugal forces for removing the fine particles. They are also known as centrifugal or inertial separators. They prevent more fine filtration methods from having to deal with large, more abrasive particles later on. Also, several cyclone separators can operate in a parallel series, and when such an arrangement is set up, then the system is known as multiple cyclone. It is important to note that cyclones can vary drastically in their size. The size of the cyclone depends largely on how much flue gas must be filtered, and thus larger operations tend to need larger cyclones. Cyclone separators work much like a centrifuge, but with a continuous feed of dirty air. In a cyclone separator, dirty flue gas is fed into a chamber. Inside this chamber exists a spiral vortex similar to a tornado. The lighter components of this gas have less inertia, so it is easier for them to be influenced by the vortex and travel up it. Unlike these particles, larger components of particulate matter have more inertia and are not as easily influenced by the vortex. Because these large particles have difficulty flowing the high-speed spiral motion of the gas and the vortex, the particles hit the inside walls of the container and drop down into a collection hopper. These chambers are shaped like an upside-down cone to promote the collection of these particles at the bottom of the container. The cleaned flue gas escapes out the top of the chamber. The advantages of cyclone are low initial cost, simple in construction and operation, low pressure drop, low maintenance requirements, continuous disposal of solid particulate matter, and use of any material in their construction that can withstand the temperature and pressure requirements. The disadvantages of cyclones include low collection efficiency for particles below 5 to 10 micron in diameter. Sware abrasion problems can occur during the striking of particles on the walls of the cyclone. And lastly, a decrease in efficiency at low particulate concentration. Typical applications of cyclones are for the control of gas-borne particulate matter in industrial operation such as cement manufacture, food and beverages, mineral processing, and textile industries. To separate dust in the disintegration operations such as rock crushing, ore handling, and sand conditioning in industries. To recover catalyst dust in the petroleum industry. And lastly, to reduce the fly ash emissions. The operating problems are number 1. Erosion. Heavy, hard, sharp-edged particles in a high concentration, moving at a high velocity in the cyclone, continuously scrape against the wall and can erode the metallic surface. Number 2 is corrosion. If the cyclone is operating below the condensation point and if reactive gases are present in the gas stream, then corrosion problems can occur. Thus, the product should be kept above the dew point or a stainless steel alloy should be used. Number 3. Build-up. A dust cake builds up on the cyclone walls, especially around the vortex finder at the ends of an internal vanes, and especially if the dust is hygroscopic, it can be a sware problem.